Welcome. In the previous 8 lectures, we have seen in detail the theoretical treatment of chemical project economics. We got introduced ourselves to the basics of the project economics, then we saw the concept of process selection, site selection, and then we saw various aspects of analysis of the project economics, the time value of money, interest, depreciation, various yardsticks that are used for analysis or evaluation of the project, that is the ratio analysis, incremental analysis, break-even analysis, discounted cash flow techniques. In this lecture and the next lecture, we shall see various problems based on the theory that we have learned. We shall first start with simple problems based on time value of money, and later on we shall see the problems on the replacement or alternative investment, and then finally we shall see a detailed evaluation of the project based on the cost data. So, let us see the first problem of today's lecture or today's tutorial. Okay. Problem 1. For the nominal annual interest rate of 8%, find the value of rupees 10,000 deposit after 6 years with continuous compounding, daily compounding and quarterly compounding. Now, we have already seen various formulae or theoretical treatment for these three kind of technique. For continuous compounding, the sum S over principal P gathered in certain amount of time is given as P into exponential R into N, where R is the interest rate and N is the period of interest. Here we are given interest rate of 8%, R is 0.08 and N is 6 years. So, we substitute values here, S is equal to 10,000 into exponential 0.08 into 6, and this gives us value of 16160.74. Okay. So, that is the value of rupees 10,000 deposit after 6 years with continuous compounding at interest rate of 8%. Now, let us see for daily compounding. Here the formula that we are going to use is S is equal to P into 1 plus R by M into N, where R is the interest rate, M is the compounding period and M into N is the total compounding periods. Okay. Now, we have to substitute various values. For P we substitute 10,000, the nominal interest rate R is 8%, okay, but it is compounded daily. So, M, the compounding period is 365 days a year, and then here at the numerator we have 365 days into 6 years. So, total compounding period, okay, and S in this case turns out to be 16159.89 rupees. So, that is a value of 10,000 rupee deposit with daily compounding. Now, let us see for quarterly compounding. Here we use the same formula, S is equal to P into 1 plus R by M into N. R is 0.08. Here M is 4 because 4 quarters in a year and N is 6 years. We substitute values and then find that the deposit value is 16084.37. So, we have the three answers for continuous compounding, for daily compounding and for quarterly compounding. Okay. So, that completes problem 1. Now, let us see second problem. Okay. I will read the problem statement for you. Two persons A and B are given rupees 10 lakh each for investment. Person A invests money in bank in the form of fixed deposit for 5 years at a nominal annual interest rate of 9%, which is compounded annually. Person B invests money in a business and deposits the net annual profit from the business in the same bank in a recurring deposit or RD account, the bank pays a nominal annual interest rate of 7% on such accounts. At the end of 5 years, if both A and B are to have the same amount of money accumulated in the bank, what should be the net annual profit from business run by person B, which he should deposit in his recurring deposit account. Now, here we have to use two formulae. Here there are two concepts. One is the concept of simple compounding and next is the annuity. Person A is going to make a fixed deposit. Okay. So, for investment of A, the net amount that is accumulated in the bank, that we denoted as subscript A, will be equal to PR into 1 plus I to the power n. Okay. That is a maturity amount. We have principal equal to 10 lakhs and interest rate is 9.5% compounded annually. So, here we make a change. Here the compounding is interest rate is 9.5% and not 9%. The annual interest rate is 9.5%. So, interest rate is 0.095 and is 5 years, the period. Okay. So, the maturity amount for A will be 10 lakh into 1 plus 0.095 raised to 5, which is equal to 15,74,240. So, that is the maturity amount of person A. Now, person B has to have the same maturity amount. However, the investment of person B is in the form of an annuity, because he is depositing the annual profit in the recurring deposit account. So, for investment of B, then the sum that will be accumulated in his bank account SB will be R by I into 1 plus I to the power n minus 1. Okay. So, this formula we have derived earlier. We substitute values here. I is 7% interest rate, N is 5. For investment of B, the formula is SB is equal to R by I into 1 plus I to the power n minus 1, where R is his annual deposit, which we have to find out. The sum that should be accumulated in the account of B is known to us, because it should be the same as in case of A. And now we substitute values and solve for R. So, R turns out to be 2,73,745. So, this should be the annual deposit of person B in his account, recurring deposit account. So, we have the answer. R is equal to 2,73,745. So, that completes problem 2. Now, let us see the third problem. This problem is on alternate comparison of alternate investment. You wish to compare two cars. one with diesel engine and the other with petrol engine. The total driving anticipated per year is 10,000 kilometers. The data for the cars is as follows. Petrol engine car, the cost is rupees 4 lakh, the mileage is 12 kilometers per liter, the lifespan is 10 years. The diesel engine car, cost is slightly less, rupees 3,50,000, the mileage is also less, 8 kilometers per liter, and the lifespan is same, 10 years. The nominal annual interest rate can be taken as 8% compounded quarterly, and the average price of petrol, which is fluctuating quite a lot. So, we take an average price of petrol as rupees 45 per liter. Okay. For what average price of diesel over 10 years, both cars will be economically at par. So, that is a question that we have. We have to find out the average cost of diesel over the period of operation, which will make the two cars economically same. So, this problem is essentially about comparison of the fixed capital investment and operating or annual expenses. So, let us see the solution. We can compare the two cars by assessing the net present value of the car with the cost of fuel over the lifespan of car, which is discounted back. Here we make an assumption that the price of fuel remains constant over the operation period. The cost of car is like fixed capital investment, and the cost of fuel is equivalent to the total production cost. So, the net present value is the initial investment I plus R by I into 1 minus 1 plus I to the power n minus 1 plus I to the power minus n. Now, this is essentially the annuity if we deposit amount R in bank in every period. Okay, this is just opposite of the formula that we have seen in the previous problem. In the previous problem, we had to compound the amount. Here we have to discount the amount. So, we have used a discounting factor here. 1 minus 1 plus I to the power minus n by I is a discounting of the annuity. I will write here I is the fixed cost of the car or paid in single installment. We assume that. And R is the recurring cost or operating charges of the car. We also assume that the other costs like maintenance, insurance, okay, these are same for both the cars. Okay. Now, let us see this thing for petrol car, the present value for petrol car. Here I is rupees 4 lakh, average petrol price is 45 rupees a liter, mileage is 12 kilometer per liter, and we have said that the total driving per year is 10,000 kilometers. So, the operating cost R is 10,000 kilometers divided by 4, because we are going to compound the interest quarterly. So, quarterly driving will be 10,000 kilometer by 4, okay. And then the total fuel that is required will be this divided by 1 by 12, because that is a mileage, okay. And then the total cost will be into 45. So, this is the kilometer per quarter, this is the mileage, liter 1 divided by kilometer per liter into rupees per liter, okay. So, this operating cost turns out to be, total operating cost over 1 quarter is rupees 9375. Or per quarter. Now, the nominal interest rate is 8% compounded quarterly. So, the quarterly interest rate is 8 by 4, that is 2%. Then the total discounted price of the fuel will be 9375 divided by 0.08 by 4 into 1 minus 0.08 by 4 raised to minus 4 into 10, where 10 years of operation, 4 quarters per year. Okay, and the net present value is then I, which is 4 lakh, plus this, the total discounted price turns out to be 2,565,000, 2,56,500, and then the total cost, total net present value NPV is 6.565 into 10 to power 5. This is for the petrol car. Now, let us do the same thing for diesel car. Here we are going to use exactly the same formulae. So, I directly put the numbers. Here initial cost is 3,50,000. We do not know the diesel price, that we have to find out. So, we assume the average diesel price over 10 years as rupees X per liter. Then mileage is given as 8 km per liter. Total annual driving is 10,000 km. So, quarterly driving is 2,500 km. Total fuel required, total diesel required per quarter is 2,500 divided by 8, okay, that is 312.5 liters. Okay. And then the net present value of the diesel car will be the initial cost 3,50,000 plus 312.5 into X, that is quarterly price of diesel divided by 0.08 by 4, that is quarterly interest rate, into 1 minus 0.08 divided by 4 raised to minus 40. So, this turns out to be 3,50,000 plus 312.5 X into 27.355, which is equal to 3,50,000 plus 8548.44 into x. Okay. Now, we have to find out x at which both of the cars will be economically at par. Okay. For both cars to be economically at par, the net present value should be same. Thus, we now compare the net present value of the petrol car, which we have found to be 6.5 lakhs or 6.565 into 10 to power 5 is equal to 3,50,000 plus 8548.44 into x. So, x after solving this, x turns out to be rupees 35.85. So, the price of diesel at which both cars are economically at par is rupees 35.85. Now, if the price of diesel goes beyond rupees 35.85, petrol car will be more economic. If it falls below 35.85, diesel car will be more economic. So, that completes the problem 3. Now, let us see the next problem. Now, here we are going to compare alternative investment using capital S cost. Now, I will read the problem statement for you. A reactor handling corrosive liquid is to be designed, and we have two options for it. First option is the material of construction MOC as mild steel, initial installed cost as rupees 50,000 and useful life only 3 years. And second reactor that we have is with material of construction stainless steel, the initial installed cost as rupees 1,50,000, okay, and useful life is not known, that is what we have to find out. We can assume that the scrap value to be 0 for both reactors and the inflation during the operational period is to be negligible. For the capital S cost for both reactors to be equal, what should be the useful life period of stainless steel reactor if the money is worth 8% compounded annually? Now, we have already derived an expression for the capital S cost, and that we write here the capital S cost K of an equipment is equal to CV plus CR divided by 1 plus I to the power n minus 1, where CV is the initial installed cost and CR is the cost of replacement. Now, we have assumed that the scrap value of both of the reactors is 0, then CR is same as CV. Okay. If there is any scrap value for the reactor, then the cost of replacement will be the initial installed cost minus the salvage value. Now, we put for the mild steel reactor numbers. For mild steel reactor, CV is 50,000, CR is also 50,000, and then K, the capital S cost, becomes $50,000 plus 50,000 divided by 1 plus 0.08 raised to 3. 3 is the operation, 3 years is the useful life, and 1.08 raised to power 3 minus 1. So, this turns out to be 50,000 plus 192,521 is equal to 242,521. Yes. So, this is the capital S cost for mild steel reactor. Now, let us see the capital S cost for the stainless steel reactor. K is 1,50,000, that is initial installed cost plus the cost of replacement, which is same, divided by 1 plus 0.08 raised to n minus 1. Okay. Now, K has to be same as that for mild steel reactor, which is equal to 242,521 rupees. That is what we have found out. Now, if you put K here and solve, for n, now we take log on both sides. And this gives n equal to 12.52. Thus, the useful life of the stainless steel reactor should be equal to 12.52 years. The capitalized cost of both equipment to be same. So, this completes problem 4. Now, let us see the fifth problem of tutorial. Here also we have to compare alternate investment, but with a different methodology. Now, let us read the problem statement. A company is considering replacement of an existing reactor with new one. The data on both reactors is as follows. The original installed cost of the existing reactor rupees 15 lakh. The annual operating cost is rupees 2.5 lakhs. Time in service old reactor is 5 years. The estimated remaining lifetime of the reactor old reactor is 3 years. The resale value is estimated in current condition as rupees 5 lakhs. Now, the data for new reactor, the initial installed cost is rupees 22 lakh, the annual operating cost is rupees 2 lakhs, the estimated lifetime is 10 years and the salvage value after 10 years is rupees 2.5 lakhs. All other costs such as labor, maintenance, insurance, etc. for the two reactors is same. Depreciation can be calculated using straight line method, and the company expects a minimum annual return of 15% on additional investment for the reactor replacement. With analysis of economic data for the two reactors, determine whether the reactor replacement meets company's expectation. Now, here we have to use a slightly different method than the capital S cost, because operating cost is also involved. Okay. So, let us start the solution. The net saving due to reactor replacement is the operating cost of old reactor plus the depreciation of old reactor minus the operating cost of new reactor plus the depreciation of new reactor. Now, we put in numbers. The operating cost of old reactor is 2,50,000 plus the depreciation 15 lakh was the original cost, resale value after 5 years is 5 lakhs divided by 5. So, this is depreciation that actually occurred over 5 years of service period. Minus the operating cost of new reactor is rupees 2 lakhs, and then the estimated depreciation is 22 lakh, which is initial cost, minus 2,50,000, which is the envisaged salvage value, divided by 10. So, this turns out to be 4,50,000 minus 3,95,000 is equal to 55,000. The additional investment that company needs to make is the installed cost of new reactor minus the salvage value of old reactor or resale value of old reactor. And this turns out to be 22 lakh minus 5 lakh, which is equal to 17 lakh. However, the net saving is only 55,000. So, the net annual return on investment is 55,000 divided by 17 lakhs, which is equal to 0.032 or 3.2%. The company's expectation is 15% return on additional investment, and the 3.2% return is much smaller than company's expectation. So, the replacement should not be made. So, that point you note, 3.2% additional return on investment is much lesser than company's expectation. Of 15%, and therefore, it is not worth to replace the reactor. So, today we have seen different problems related to the time value of money, interest, compounding, discounting, etc. We shall do actual analysis of project cost based on the total capital investment, the fixed capital, the operating capital and the net sales, and then we shall try to find out as how we can best evaluate a project using ratio analysis, break-even analysis and discounted cash flow techniques. Let us see a problem on profitability analysis of a chemical plant. The problem statement is now appearing on the screen. After conceptual design and estimates of a chemical plant, the following expenditures and revenues are estimated after the plant has achieved the desired production rate. Okay. First, the total capital investment is rupees 10 crore. Working capital is rupees 1 crore, annual sales are rupees 8 crore, annual expenditures or the total production cost is rupees 2 crore. We assume a straight line depreciation over 10 years of project life. The tax rate is estimated at 35% and we have to determine the return on investment after taxes and the payback period for the plant. Now, let us start the solution. We know that the profit before tax is equal to the annual sales or revenue minus the total production cost minus the depreciation. Now, we substitute values. Profit before tax is equal to annual sales, which is 8 crore, minus the annual expenditure 2 crore or total production cost, minus the depreciation, and it is at straight line. So, 10 crore divided by 10 years of project life. We assume salvage value to be 0. Here we note that point, assuming salvage value of plant equipment to be 0. And then we get profit before tax as rupees 5 crore. Now, we have been given income tax at 35%. So, the profit after tax is 1 minus 0.350 into the profit before tax 5 crore, and this turns out to be rupees 3.25 crore. Now, with this we have to calculate the return on investment. Return on investment is the net profit or profit after tax divided by the total capital investment. And then we substitute values, 3.25 crore divided by 10 crore, which is equal to 32.5%. So, that is return on investment. Next, we have to calculate the payback period. Payback period is defined as fixed capital divided by the net cash accrual. Net cash accrual or net cash flow, as some books call it, is equal to the profit after tax plus the depreciation, and then this is equal to 3.25 crore plus 1 crore of depreciation, that is equal to 4.25 crores, and then payback period, substitute values, is equal to fixed capital, but fixed capital is equal to the total capital investment minus the working capital divided by net cash accrual. So, 10 crore is the total capital investment out of which 1 crore is the working capital divided by 4.25 crore. This turns out to be 2.18 years. So, the payback period for the plant is 2.18 years. Okay. Now, let us see one problem involving time value of money. I will read the problem statement. A reactor in a chemical plant uses CNG or compressed natural gas with calorific value of 50 megajoules per kg for heating. The annual energy consumption of the reactor is 200 gigajoules. The company plans to make energy integration of the plant, as a part of which this reactor will be heat integrated with other hot streams in the process. And obviously, this would save a net energy consumption of 200 gigajoules per year. The additional fixed capital investment required for the installation of heat integration system is estimated at rupees 5 lakh, and the expected lifetime of this system is 5 years. If the money is worth an annual interest rate of 8% compounded annually, then we have to find first the break even cost of compressed natural gas for the additional investment of company, assuming prices of CNG to remain constant over the 5-year operational period. And then secondly, if the prices of CNG are expected to rise by 10% each year, determine the break even cost of CNG. Now, here we note a point that at break even, the plant makes neither profit nor loss. We have not been given here the period of construction of the heat recovery system or heat integration system, but then we can make assumption that all of the investment for the installation of heat integration system is done at once and at time equal to 0. That assumption we note. Assumption: all investment for installation of heat recovery system or heat integration system is done in single installment at time equal to 0. Now, we have to calculate the break even cost of compressed natural gas. For that, we have to estimate the energy savings, the money worth energy savings over 5-year period, and that we have to discount back to time 0 and see whether it is equal to rupees 5 lakh of investment. Okay. So, that is the approach. That point we note here. For determining the break even cost of CNG, we have to discount back the money saved due to energy saving, money saved due to energy integration, and equate it to the investment for heat integration. Now, the net CNG consumption of the reactor is 200 gigajoule divided by the calorific value of CNG 50 megajoule per kg, that is 4000 kgs. Now we assume the current price of CNG to be rupees X per kg, and then the net annual saving due to energy integration is 4000 into X. We equate the present values or net present values of investment and earnings or savings in this case at time 0. Now, for first year, the profit of 4000x we assume to occur at the end of the year, and then the net present value of this money is 4000x divided by 1 plus I. Then second year, here again we assume 4000x because x is assumed to remain constant, and then the net present value is 4000x divided by 1 plus I square. So, this is the net present value of the savings in the second year at time equal to 0. In this way, we can sum up. So, 4000x divided by 1 plus I plus 4000x divided by 1 plus I square plus 4000x divided by 1 plus I cube plus 4000x divided by 1 plus I raised to 4 plus 4000x divided by 1 plus I to the power 5, and is equal to rupees 5 lakh investment. And interest rate we have been given as 0.08 or 8%, and then after substitution we get 4000x we can take common, and then after putting 0.08 in place of I and summing up the series we get 3.993. This you can easily work out on a calculator, which is equal to 5 lakh, and then x is 31.3. So, this is the price of CNG at which there is no profit or no loss, or the break even price. Break even price in rupees per kg. Okay. So, that is the solution to the first problem. Now, in the second sub problem, we have been given that the cost of CNG is expected to rise annually by 10%. Section B, this rise of price of CNG annually by 10%. Now, in this case, we have to do exactly same thing. However, our net earnings is going to increase in time, with time, because the price of CNG is going to rise. We are going to save CNG due to energy integration. So, the savings is going to rise. In the first year, it is going to be same 4000x divided by 1 plus I, or I equal to 0.08. In the second year, the price is going to rise 10%. So, we have to multiply the earnings of second year by 1.1. The denominator is 1 plus I square. In the third year, 10% again over 1.1. So, 1.21 into 4000x 1 plus I cube, and then 1.331 into 4000x 1 plus 0.08 square plus and this is equal to 5000. Now again you take 4000x common from right hand side and work out the series. That turns out to be 4.804. You can easily work out on a calculator. This is equal to 500,000 or 5 lakh, and then x equal to 26.02. So this is the break even price of CNG in rupees per kg. So if the prices of CNG are going to rise or expected to rise, then we save more, and therefore the break even price comes down 26. That means the system is profitable if the prices of CNG are more than the break even price. This means that the heat integration system is profitable if the prices of CNG are higher than the break even price. So this completes the first tutorial of chemical project economics. In the next tutorial, we shall also see problems related to depreciation, profitability analysis, ratio analysis, replacement, etc.